It goes without saying that everyone is familiar with Putzmeister Betonpumpen, a manufacturer of highly specialized equipment for pumping concrete. SLF was recently commissioned to erect a modern and cost-effective coating station to fit the dimensions of the Putzmeister facility here in Glundau. The unit was designed to handle a coating throughput rate of up to 20 kilograms per hour and to comply with all emission limits. The conceptual design included temperature control of the workspace, as well as equipment for drying the long workpieces. Because it was necessary to provide for a way to receive and transport workpieces on an ongoing basis, the only appropriate design was a free spray coating station. Another consideration was the fact that other manufacturing departments are located upstream of the coating station because of the open space design of the overall building. Given such conditions, cost-effective air handling is only possible through the use of long-range nozzles. 14 of these nozzles are mounted on the ceiling above the building's 8-meter-high overhead crane. In the coating process used here, heated air is fed to the coating station from above and is then extracted through the floor, cleaned, heated, and then returned to the process loop. The sketch shows the targeted airstream, which can be directed from a height of up to 20 meters directly at the coating technician. The high exit impulse of the airstream induces a flow of additional air from inside the hall, making it possible to achieve the minimum air settling speed of at least 0.3 meters per second across the entire workspace. Special attention should be paid here to the heavy-duty impact separator, which replaces the conventional grating. The principle of the impact separator is based on interlocking U-shaped profiles. The majority of the overspray and coarse debris collects in the basin-like shape of the bottom U-shaped profile. With this patent-pending process, the impact separator system can also be cleaned during operation. The unit does not need to be emptied, as would be the case if cleaning a grate base system. The remaining fine dust and coating material is collected in the separation cartridges that are mounted directly before the vertical exhaust air unit. These can be easily exchanged via a maintenance hatch in the horizontal extraction duct. The fact that filter mats must no longer capture coarse debris substantially increases the service life of the mats when compared to conventional technologies using coating filters installed beneath an extraction grate. This drastically lowers disposal time and disposal costs. Using a series connection, one and the same ventilation system can be used to supply or extract clean heated air from one or more workstations with substantial savings in energy costs. This technology, which has been awarded a design patent for its ability to automatically switch between different segments, uses a motion-based person recognition system. Roughly 80% of the extraction effect is allocated to the workstation currently in use, effectively demonstrating the use of vertical ventilation. For this purpose, several cameras are positioned on the ceiling between the long-range nozzles. A computer program developed especially for this purpose recognizes every movement of the coating technician. This signal is fed to the computer, which simultaneously switches the long-range nozzles in this section to vertical ventilation, while also opening the impact separator systems in the floor ducts beneath the nozzles. This supplies a targeted stream of heated fresh air to the coating technician. In effect, the technician takes a supply of fresh air with him as he moves. The remaining impact separator systems in the floor ducts are in a closed position. After application of the base coat, or even more importantly, after the application of the final coat, the drying time is dramatically shortened through the use of a telescoping dryer cabin. The cabin segments, which until now have been retracted in their so-called parked position, can now be fully or even partially extended to begin the drying process. With a parked footprint of 7 by 5 meters and 5 cabin segments, the cabin can in this case completely surround a workpiece with a length of 30 meters. In this cabin with longitudinal ventilation, drying temperatures of approximately 60 degrees Celsius can be achieved. Here at Putzmeister, all booms are installed and functionally tested before they receive a top coat. A complete hydraulic unit was installed in the first segment of the dryer cabin for this purpose. In this way, all articulated sections can be positioned for coating, a function that could not have been implemented in a standard cabin. In order to protect the floor from overspray occurring outside of the extraction area, we installed our quick clean system. In this system, a plastic film attached to a ground level grate is drawn tight to the ground using negative pressure. The floor area is connected to the fan on the suction side by a duct, so that the high negative pressure applied to the plastic film keeps it in place, even when walked on with sticky shoes. This film captures the remaining overspray. Maintenance is minimal because the soiled film need only be rolled up and replaced from time to time. This process has proven itself time and again for 2-component and 3-component coating systems that apply coating films with thicknesses up to 1,000 micrometers. The coating storage area is located in a separate room next to the machinery plant. Metering of primer, thinners, and hardening agents takes place here. Pumps for the top coat are within easy reach of the coating technician in the main hall. The degree of turbulence associated with the ventilation system of a free spray coating station equipped with long-range nozzles is somewhat higher than in the case of a closed cabin. However, the quality of the air supply ensures perfect coating results for high-end applications in mechanical engineering.